Here I would like to do a quick overview of superspace theory and how understanding the fourth dimension will show us what we are missing in our physics today. So here is a short overview that I've written out, and it starts with the direction of small is the fourth dimension. So the direction of small is the fourth dimension. And what does that mean? It means, let's make that invisible. It means, and let's make our brush a little bigger. It means that what we think of as the very small is actually a fundamentally different spatial dimension or direction leading outside of our own 3D space. So if we think of our universe from a two-dimensional analogy, a lower dimensional analogy, we can think of it as a sheet of space with two fundamental dimensions or degrees of freedom. And we can think of the very small, the subatomic levels of physics, as a direction moving into a fourth spatial dimension. So when we move inward to fundamentally smaller levels of physics, we are no longer getting smaller, we are moving further away in this fourth spatial dimension or direction. And so that's what I mean when I say size equals distance at fundamentally smaller levels of physics. Size is distance. Size equals distance at fundamentally smaller levels of physics. There are deeper fields of space that lie alongside our own, and these are the fields which hold the phenomena of what we think of as the very small, but instead of them being smaller, they are actually further away or distant in this fourth fundamental direction or fourth dimension lying alongside our own 3D universe. So let's go over this with some of the charts from the Superspace book. Here you can see that our own universe is this sheet, and this is a two-dimensional analogy. It's this sheet of space with deeper fields or sheets, I prefer the term fields, lying alongside it. So as we move inward, we are actually curving into a fourth spatial dimension. In this image, I show how the flat view, when we are thinking of space in linear terms, we think that things just have to get smaller and smaller and smaller. We have nowhere to go with this, so the only way we can think of it as things getting smaller and smaller, which is not what the math actually says. It actually is stating that there's this direction that moves infinitely inward or infinitely forward or deeper, but the math isn't actually speaking of size when we get into the realms of very small. It's actually talking about a direction. And so we can look at what we think of as small, we can see it as a tunnel. See how if you looked at this as a tunnel, right? If you were facing a tunnel in it had, sort of corrugated walls, and you'd see these circles going in toward maybe a light or something where the arrow ends here. That could be a tunnel, right? Here's a wall, and here's a tunnel. So that's exactly what it is. As hard as it is to get our mind around, that's exactly what it is when we are talking about the realms of the very small. They are no longer smaller. They are further away in these deeper fields of space. Okay? And so if we move into the subatomic, and these should actually be, I say, nucleons. I can't write with my mouse, but that says nucleons. So in the macro universe, things have size. There's bigger and smaller things, obviously. But then when we move into the realms of the very small, nucleons, quarks, superstrings, quantum foam, Higgs boson maybe somewhere around here. Let's go Higgs. And again, I can't write, but that says Higgs. Okay, so now we are moving into these deeper fields of space. And what we think of as quantum particles are actually, well, you could say excitations like quantum field theory, but they're actually holes, energetic holes, in deeper fields of space lying alongside the three-dimensional field of our own universe. And so we just saw deeper fields of space lying alongside our own three-dimensional universe. And it's best to look at fundamental particles in this sense as holes in deeper fields of space. So these fields of space lie alongside each other. They're not all in the same spatial dimension of our 3D universe. They are going deeper in this fourth dimensional direction. And that's the nature of quantum particles are determined by the location of the field in this deeper multidimensional space. So being a hole, again, I don't think that should be atoms. Being a hole, they have a horizon, like a black hole or like maybe a star. They have a horizon, and they can be energetic. The energy can leap up to different fields or leap down to lower or decay down to lower fields. But these fields aren't just lower and higher in sort of a, as an analogy. They are literally lower and higher within the deeper dimensional fields of a multi-dimensional greater universe. And so when we see that, we can also see that heavenly bodies are the same way, that they are also holes in the field of our own universe, and that gravity, the curvature of gravity, is the curvature of holes, and that curvature is curving into the fourth dimension. The curvature of gravity curves into the fourth dimension, in this fourth fundamentally different spatial direction. The gravity curves inward into the realms of what we think of as the very small, which is actually a fourth spatial dimension. So gravity is curving into the fourth dimension, which is what we think of as the realms of the very small. Now, the last couple quick things that make this theory, complete this theory, are that when we look at our universe as a field of space with deeper fields lying alongside it, with fundamental phenomena being held within deeper fields, and that determining their nature, fundamental particles. This greater block universe, what I call the block universe, of multiple dimensions is moving from an energetic dimension into an entropic one. The reason this movement is important because the movement explains some of the phenomena that we observe. Namely, this greater motion is what we experience as time. So time is not a fourth dimension. Time is motion through this fourth dimension, motion through this fourth spatial dimension. The fourth dimension is the realms of the very small. The fourth dimension is when we curve inward into fundamentally smaller levels of physics, and time is the motion of this greater block universe. So you can say it's motion of or through the fourth dimension rather than the fourth dimension itself, although those are clearly very interrelated. So when we understand this, the final thing that I would like to touch on briefly, that I touch on in more detail elsewhere, is that this motion and the curvature of our field of space due to heavenly bodies as wholes, the motion is what creates what we experience as the force of gravity. So something moving in linear space, if this linear space is moving upward in this fourth dimensional direction, then the linear object will get swallowed by the moving whole. So that's why Einstein's equivalency principle, what it actually means. So, right, Einstein said that someone in a box in space that's accelerating would be pressed back against the wall, and that would be equivalent to the force of gravity, but he never quite explained what this all means. Well, what it actually means is it's literally the fact that our spatial field, the spatial field of our universe, is actually moving in a fundamentally fourth direction, and that things moving through linear space will curve inward until they're blocked. So I won't get into that in too much detail, but that's what I call the unification of gravity and time. That time creates what we think of as the gravitational force, along with the curvature of space. But I think what's most important here is understanding the fourth dimension, that what we think of as the very small is a fundamentally different spatial dimension, a fourth spatial dimension outside of our own 3D universe, and that when we move into the realms of the very small, we are actually moving. Let's see if I can pull up a brush. That is working. So when we move into the realms of the very small, so here's our universe, and here's the fields beneath it, and these are the realms of the very small. So instead of looking at things as getting smaller, we can look at this as a tunnel going inward, and that when we move in the direction of what's fundamentally smaller, the subatomic, we're moving in a fourth direction, a fourth dimension. The realms of the very small are in a fourth dimensional direction. So that is the main principle that we are missing, is the fourth dimension is in the direction of small. The fourth dimension, outside of our own 3D universe, is in the direction of what we think of as the very small. That is what we need to understand.